because we will post this to the wiki page after the presentation is over. So anybody wants to go back and check out the recording later, you can. Just a few updates, up and coming training for Open Roads Designer. We've previously had a class scheduled in February and May. The February one was actually in person, and then the May one was canceled due to only one person signing up. And then, of course, with this this whole COVID thing going on, we've made the additional training classes for the remainder of the year as virtual Teams meetings. Those are available for sign up in ODOT Learn. So August 10th and 11th will be the next one, and then November 2nd and 3rd as well. So if you want to sign up for any additional ORD training, or if you have new staff that need training, please have them go sign up in ODOT Learn. Just wanted to mention the wiki page. This is where we're holding all of the available training content along with the recordings of these CAD webinars. So they will be placed there at the end of this. So as I mentioned before, this is the June webinar for driveways. We have these once a month just to kind of go over, different topics with Open Roads Designer, things that we've covered in the past, things like right-of-way parcels, advanced templates, things like that. This will be ongoing till the end of the year. And then in August and December, this is going to be kind of an open topics session. So I don't know how you guys handling that. Are you just taking requests for that, or are you just whatever you guys decide to come up with for the open topics ones?
I think JD for the last one had sort of solicited feedback from everyone.
Okay.
We only got one suggestion, and that's what we ran with. So I guess that's a call for any topics that anyone out there listening might have. Let us know what you would like to see.
Yeah, great. And then we did have bi-monthly open sessions set up where you could come in and, just kind of, open forum, ask questions, work through some issues, things like that. Those have been canceled, obviously, because of the this whole COVID thing. So no in sessions are available yet. This, we could potentially maybe do something like this virtually. I think this is kind of still open for discussion as far as, trying to set something up. So we'll leave it at that, and maybe start having those in the future here. And then internal CAD managers meetings, we have one scheduled for July 22nd. That is a Teams meeting, and those will continue to be Teams meetings for the foreseeable future until everybody reconvenes in the office. But for now, July 22nd is the next internal CAD managers meeting. And then our next external CAD users group meeting is scheduled for September 2nd, and that's a live Teams event. We had one just earlier this month, June 22nd. Actually, we got a lot of positive feedback on that one. It went really well. It was about a half a day, about 4 hours. So just look for those in the future. Those will continue to be Teams live events. And then just real quick, today's presentations will be done by Matt Ivan in our office, as well as Eric Thomas. And I believe we've got this scheduled for an hour, but it sounds like they've got quite a bit of content to go through. So this may run over an hour. So just to keep that in mind. Is there anything else you guys want to do, or you want to just take it from here?
I can take it unless Eric has anything else.
Sounds good, Matt. You're on.
All right. Share my screen. Okay, so for my portion today, I was going to take a look at creating driveway geometry and modeling using a civil cell. Then we'll go over just a couple quick demos on placing some geometry manually, or what you might call a site modeling workflow. It's probably a safe assumption that most everyone on this call is familiar with a microstation cell, like a pre-made design or feature that can be placed in our design file. These are stored in cell libraries, easily accessible. And the whole reason for those is, they can be reused over and over. But they're static and cannot be used with civil geometry. So they definitely have a purpose, especially for point features or maybe cookie cutter designs. But today's design and modeling, our 3D environment, a civil cell can be much more powerful. So what is a civil cell? It's a collection of civil elements such as geometry, templates, and terrain models. It's like a self-contained design that can be placed repeatedly in a design. Compared to a microstation cell, it can be modified once it's placed using ruled geometry elements. So, most of what I'm going to cover today will show creating a driveway and modeling with a civil cell. Please don't take the civil cell method as the only way to model a driveway. Civil geometry, corridors, site modeling sort of approach can also be used, and maybe the best in some cases. If a longer driveway, or especially if you have a longer driveway or one with maybe some more complex geometry. So what I wanted to start with was show all of the driveway civil cells currently in the ODOT workspace. And these were created some time ago, and some of them may need revisited. As I kind of scroll through here, you may see some issues that jump out. So what I did was create a dummy terrain file, an alignment, and a corridor with a couple of different templates, and then place the civil cell on the left and right side each. So from left to right, we have the driveway designs as in the L&D. So those are the different figure numbers, 803-2 for the urban residential, and then 803-8 for the commercial, 803-9 for the shopping center. And then on the right, I have the drives as defined in standard drawing BP 4.1. So I'm just going to start by zooming in here on one of these on the left, and I place the civil cell, and any of this geometry that's been placed in here can be modified. So if I wanted to just change my center line, I could do that. Let me zoom back out. Well, I might have placed it that was ruled. If I change the geometry on this side, it should be able to work. So as soon as I change this, it's taking its time thinking about it. The civil cell updates all the geometry to go with it. And then if I wanted to change any of the features here or any of the dimensions, I could do that by clicking on those elements. And maybe I want this to be just say 8-foot radius for that return, and the cell will update itself. So you can see how this could be advantageous in many cases. And then if we look at the 3D view, I'm not going to go through each one of these, but if we look at the 3D view, we can see that it automatically places these elements in the 3D, also creates a surface terrain and places a surface template on it. So we have a pavement buildup for each one of these. Where my cursor is at on these two on the right hand side, I don't know, this might have been user error, but it might be something with the cell as well. I got some weird issue where everything's dropping down to 0 right here. So that's something that might need looked at. If I scroll to the right, you'll see that the cells for the BP 4.1 examples include a surface terrain, but they don't include a surface template. So there's no pavement buildup on these, and that could be added pretty easily. So that said, that's a quick example of what we have. And I'm going to jump over to a sort of a recording. I apologize. I feel like I'm cheating when I do that, but it just makes things go a whole lot smoother. So I'll have to reshare. I forgot to share the audio.
for the sake of time, using the ODOT Create Design Files app, I've already created a new BK file, BK006, which is the file I have open. And I'll use this file to place my centerline geometry. I've also created a new KM file for my modeling, so I've named it KM006, and I just used the same 006 suffix so that I can keep track of those files and that they go together. In each file, I've attached my fieldbook file and set the terrain to active, and I've also created a I've also attached the BK004 file, which is my State Route 185 centerline geometry, and attached the KM001 file, which is the State Route 185 corridor model. In the KM006 file that I also created, I went ahead and attached my BK006 file, which it's just going to have my drive geometry in it. So when we get to that point, that will already be attached. Now I'm ready to go ahead and create my drive centerline. So I'm going to start by using, or from the feature definition toolbar, I'm going to set the use active feature definition toggle on, and I want to set my alignment to centerline of proposed driveway. And the use active feature definition will just allow each command to go ahead and use this feature definition rather than me having to remember to set it in each command. So from geometry, then I want to place a line between 2 points. Before I do that, though, I do want to toggle on my civil AccuDrop, and I want to use the station and offset coordinate. And when I start my centerline, what I want to do is I'm going to start from the left of my centerline. Now keep in mind, 185 centerline goes from north to south, so the left side is actually the right side of my view here. So I'm going to start from the left side of the center line and go to my center line of State Route 185. This way my profile will appear looking up station just as my cross sections would. So I'll go to place line between 2 points. And before I start, I need to toggle to the offset field here, and I'm going to press O for origin. And this will allow me to select the reference element, which was the State Route 185 center line, so that the civil AccuDraw has some coordinates to work from. So then I'll set my station at 388 plus 45, and my offset to be -100. Now data point to accept, and keep my 388 plus 45 station, and my offset this time will be 0 to match the center line of 185. And then I'll data point to accept. So I have my profile in plan view. I didn't mention anything about my name. I just went ahead and kept it as the default CLP_drive1. Now I'm ready to create the profile for my center line. I think I previously called that my profile there in my plan view. But anyways, we will start by using the open profile model, and I will identify my drive center line, and then I'll data point in my view 4, which is where I want my profile to open. So we see our existing ground profile here. And next thing I want to do is I'm going to zoom out just a tad here, and I want to use the profile intersection point to identify the vertical location of the center line of the State Route 185, the edge of pavement, and my edge of shoulder. This will plot those points in my profile view. So I'll select this command, and then I'll identify my center line again, and then I'll locate the elements which it crosses or intersects to plot those points. So when I select State Route 185, you'll notice this magenta point is placed, and then I'll select the edge of pavement and the edge of shoulder. And hopefully you can see those. They are there, I promise. If you can't, they show up as the same symbology as the edge of pavement and edge of shoulder do. So await 2 and await 1 point. So now I'm ready to go ahead and start creating my profile. So I'm going to use Profile Complex by PI. And again, I'm going to use my Civil AccuDraw, which is on, and I'm going to use the profile offset origin. So first thing I need to do is it's asking me to pick a profile view, so I'll just identify my view 4. Now I'm ready to go ahead and begin. And what I want to start with is go to the profile offset field and press the O key for origin again, and I'm going to select a reference element, and this reference element is going to be my existing ground. Because the first point I want to match my existing ground exactly. So I'm going to tab now for my station field, and at 0 plus 40 is where I'm going to begin my center line. And I want my profile offset to be zero. So now I'm at 0 plus 40, and an profile offset is 0. I'll data point to accept it. And then the rest of my profile, I'm just going to go ahead and snap to those points for the edge of shoulder, and edge of pavement, and my center line. So there's my profile. And then I can go ahead and review that if I wanted to just make sure that my grade breaks were acceptable. I think we're okay here in this example. So now what I need to do is go ahead and set my profile to active. So I'm just going to go ahead and select on my profile and select set as active profile. And when I do that, we'll see that our profile appears in our 3D view. There are two other things I just wanted to point out. First is that this view is exaggerated, and you can change the setting. That's just your personal preference. If you wanted to set your exaggeration differently, if we didn't like it exaggerated, we could set it to a vertical exaggeration of 1. And we have some other options all the way up to 100. I was in an exaggeration of 5 when I started. So you can change that however you feel, or whatever your personal preference is. The other is we can also, along with setting the points or placing those profile points and selecting the edge of pavement and edge of shoulder, we could also do a 3D cut of the model that's in our 3D view and have it draw in the pavement layers so you could see those as well. So I'll do that real fast. I'm going to go to the Create 3D Cut on my profile toolbar here. And I'm going to use the placement method of corners. And I'm just going to select 2 points in my view. When I do that, I get a boundary here where the cut is at. I'm not sure if there's a bug or something here, but it's actually cut. All the levels of my 3D reference are turned off. So I'm just going to turn those on real quick. And then if I click the update or refresh 3D cut button, the pavement layers are then populated. So for my profile, I really don't care what this grading is, so we can modify that boundary by clicking and dragging. Could also snap, let's see, I guess, yeah, snap to the end of that line, change my boundary box, and hit refresh. And now I'm only seeing the lane and the shoulder pavement built up here. But you may find that one or both of those options are handy for you. Again, both personal preferences here. You could also use these to create a profile with the 3D cut and snap to those elements as well. Now I'm ready to go ahead and begin modeling my driveway. And what I want to do first is I want to go ahead and switch to the KM file that I created. So that's KM006. And just to review what I mentioned earlier is in my file here, I went ahead and already attached my field book file, set the terrain as active, and attached the center line of 185, my corridor model for 185, as well as the BK006, which has my proposed driveway center line and profile line. And we'll see that those show up in both our plan view and our 3D view. So now to place my civil cell, I'm going to go to the Modeling Detail tab and select on Place Civil Cell. And then from the dialog box, I'm going to click on the ellipsis, and this will give me the options of, or show me which civil cells are available to use. In this scenario, I'm going to use one of these from figure 803-8, which is one of the commercial drives, rather than one of the EP 4.1 standard drawing type 2, for example. If I select on this, you'll see the reference elements that it's going to ask me for, how this is going to be built. So it's going to ask me to select on the center line of my drive and then the edge of pavement line. So in this civil cell, it would construct the driveway from the edge of pavement. Well, in my particular design, my shoulder buildup is the same as my lane buildup. So I would want that pavement buildup to carry through the driveway rather than have the drive buildup intersect in the middle of the shoulder. So if we look at the uncurved highway with shoulder chamfered, you'll see now I have 3 red lines that are reference elements. So I have my drive center line, the edge of pavement, and then edge of shoulder. So in this scenario, it's going to begin constructing my driveway at the edge of shoulder line instead. That way I still can use the edge of shoulder or the shoulder buildup through the driveway area. So when I click OK now, I'm going to be prompted to select the driveway center line. And then it's going to prompt me to locate the reference element for the edge of pavement. And I'm also prompted now to locate the edge of shoulder. And when I do that, you can see it's trying to solve for my driveway, but because of the direction that I drew my center line, it's not quite giving me the desired result at this point. So as you can see, if I move my cursor along the drive or along the edge of pavement line, or even the edge of shoulder, it's allowing me to define the direction that these are going. So I'm going to start by changing the direction on the driveway center line. And you'll see I get some different options here, still not what I want. So I'm going to go to my edge of pavement and I'm going to change the direction of it. So that looks more like what I would like. And so I'll reset now to finish that, and then data point to go ahead and place the civil cell. And when we do that, you'll notice that it's triangulated already. There's a surface terrain created, as well as a surface template is placed on there to give me the correct, or not, give me a pavement buildup. This may or may not be correct, and for my particular case here, since this is probably more of a residential drive, and I use the commercial drive template or a cell. So we can change that in a second, but I just wanted to point out that it goes ahead and places the pavement layers here. So we have a surface course and some aggregate here. Okay, so now I just wanted to take a look at how we can quickly review some of the properties of this cell by using the properties dialog and selecting on the cell itself. And we'll notice we get some general information about the civil cell levels and things like that. But we're also going to get a line for each of the courses of this pavement buildup. So I have an asphalt surface course and an aggregate base. And probably what most people will find most useful is that I can get the quantities or the component quantities from this as a check, or even to use for my quantity calculations. So in this case, we have 189 yards of surface course, and we have 568 yards of aggregate base. If I wanted to change that surface template that was used, I can select on the ellipsis beside template name, and this will take me to my ITL file for my project. And we're going to look at the ODOT folder under components and drives, and these drive buildups are from the L&D. And I'm going to go ahead and select buildup 1, which is going to be the concrete drive, a non-reinforced concrete buildup. And you'll see in my 3D model that changes already. And now when I select on my surface mesh again, you'll see now I have a non-reinforced concrete pavement line here, and you'll see I have 757 cubic yards of concrete. So if you were to want or had a different buildup for your drive than what's in the standard components, we could create a new surface template to do that. And what you would do is just go to the corridor and tab, and then to your template library, and in your project templates, I had done some testing here with this one, but what we could do is just create a new template, and I'll just call this test surface, and we could go ahead and add in components. Probably the easiest way to start would be to maybe start with the ODOT components under drive, and maybe we needed to edit this, something similar to this, but our thickness was different. Maybe we wanted this to be 3 inches. We could change that for all those points. And that way you have a surface template that's custom for your project or custom for whatever you need. So maybe your aggregate base is thicker, whatever the case might be. Once we do that and we save it, and now if I go back to my list here under my project templates, I see the test surface that I just created, and I could apply that one to this as well. So let's continue reviewing how this was created. First, what I want to do is turn off some stuff just to clean up my view. And from my 3D view, I want to turn off these surface triangles and my tin hull. Before I turn that tin hull off completely, you'll notice that this blue line is actually the limit of my drive profile. So I need to shorten up the length that the edges of the drive were shown in here. So it's also in, it's probably very difficult to see, but it's also in here from the profile, and that's what I'm going to use to snap to that here in a second. So I'll turn off that so I can see things better. I'm also going to go ahead and turn off the edge of pavement for my driveway. I think it's a concrete pad. There we go. And just to, you know, you can see those trees. So now if I go to my element select, and I'll zoom out of my 3D view so we can take a look at this as well while it's happening. If I select on the edges of the drive, I should be given the dimensions or the how this was created. But notice that these are gray. So in order to change the any of these fields for the underlying element there, we need to right click on it and they'll change it to orange. So now I can use the manipulators handlebars or edit any of these values as needed. So if I wanted to, here I'm going to click and drag, and I'm going to snap to that point in my 3D view that is the limit of my profile. And I'm going to do the same thing for the other side. And then next, let's say that I wanted to change the width of this. There we go. Maybe I can change this to 8 feet, and you'll notice that I can change this and updates the terrain model for the drive. And then next, let's maybe say we wanted to change the chamfer here. And maybe I just want it to be a little bit closer to what the existing condition was. I can also change those. And both of those change. So that's all the editing I'm going to do on this for the moment. Next thing we're going to take a look at is we want to remove the corridor model from State Route 185 corridor. So now I switch to my KM001 file. That's my corridor model for State Route 185. And first thing I need to do is go ahead and attach the files that we just created for the driveway. So I'm going to attach both the BK006 file, and I'll also attach my KM006 file. Oops. Okay, so now we see our plan view and our 3D view here. And what I want to do is, we've covered this in some other online videos and maybe even in some other webinars, but in our template for State Route 185, if you look at these couple of null points that appear above the template itself, we'll look at the drive left since we're on the left side. If this point, if I test where this point falls, as soon as it falls anywhere beyond the center line or 0, the shoulder steps and the grading are removed. Our end conditions are removed. And that is because we have some rules set up here, and we can look at this two ways. So if we look at the point, we have a label that's set up as drive left. If we were to use a parametric constraint and set it from one station to another, and as long as it's any other value to the left of the center line, it will turn off those end conditions. We can also use this horizontal feature constraint. So if we were to draw an element in our line that was on this feature, using this feature match line, drive match line, it would also remove the end condition for that particular limit that you drew the line for. So probably in the past, I used to like the parametric constraint easier because I could just type in where I wanted to, but more recently I've started to kind of like the match line. And really the main reason for that is because I have a visual line that I can see showing me that there's a constraint there that's being used. And if I were to look at one of these components and I look at the rule, it says not drive left. So if I were to edit that, as long as it is anything greater than 0.01, that will remove the end conditions. Okay, so from my feature definition toggle here, what I'm going to do is go to linear, modeling, template points, and I think it's miscellaneous, and I have a drive match line here. So I'm going to place the line here, and I'm going to go to geometry tab, and I'm going to use my offsets and taper. And I'm going to do single offset partial. And my feature is being used because I have my use active feature definition toggled on. And as long as this, I forgot to point out in the template, in that particular template, I think it was set to 100 feet. So as long as this offset value is anything within that 100 feet that it's looking or searching for this, it will remove that. If it's greater than that, or on the other side, it will not work. So if I select my center line, and I'm going to keep the 50-foot offset, and we found that if you snap to the end of the drive, it doesn't really work. But if we use our civil AccuDraw to kind of come up with the station, try that again. So if I snap there, and that says it's at 388 plus 26, I enter that station in, and I do the same thing. 388 plus 66, and enter that in as well. And then I don't want to mirror it. So nothing happens right away, but what I have to do is add that as part of my corridor as a corridor reference. So if I add a corridor reference, select my handlebar for my corridor, and then I'll select my reference line, and I'll reset to complete. And as the corridor processes, it removes the end condition through the area of the drive. But what you do see is a little bit of a gap here. And if I turn on my 3D view, or excuse me, in my plan view, if I turn my 3D view on, you'll see that each one of these lines here is a template drop, which I had pretty tight in this particular corridor, but I really wanted it to stop or start a new, carry the corridor all the way up to the driveway here. So in this case, what I'm going to do is I can add a key station. So it'll cut place another template drop at that station. And in the same fashion I did there, I want it just to be off just a little bit from where we had. So I'm going to make this 388 plus 66.01. And I do that, my corridor is processed, and I should have another template drop. So it takes me over to the end. So then if I do that on the other side, I'll select, and if I snap to the end here, it's 388 plus 26. So let me just back that off a little bit. So 388 plus 25.98 maybe data point, and it'll drop in another template drop at that location. Now that we've edited our corridor for State Route 185, I'm going to go ahead and return to my KM006, or my model file for my driveway. And when we get there, we'll see that that corridor is referenced and it's clipped out here as well. Now what I want to do is take a look at adding some grading to the edges of each driveway. And I'm going to look at two different ways to do that. First is going to be using a linear template. So in my template library for my project, I've just copied the 4:1 fill slope end condition, and I modified the graded shoulder width, and that was all it changed. So then I'm going to go to modeling detail, and I'm going to select apply linear template. And I'm just going to select each one of these edges and accept through the prompts, data point through the prompts, and it will add our grading here. So we have some overlapping grading with these two linear template corridors that were created. And if I turn on the main line grading, you'll see we also have a little bit of overlapping here. So we could use some corridor clipping and maybe even some target aliasing to get those cleaned up. So the second way that we can take a look at some grading on the opposite side is we're going to use maybe a site modeling approach. So what I'm going to do is use this 3D view, and I'm going to go to my drawing tab and place a smart line. And in my 3D view, I'm going to snap to the points in my model. I'm going to create a 3D line here. So I'm snapping to the back of the driveway. So now I have a line here, 3D line, and then I'm going to use the 3D components from my model to create a terrain. So I'm going to go to the terrain tab and use create a terrain from elements, and in my feature definition I'm going to create as a proposed triangles. So I'm going to select the 3D line that I just drew, and then I'm going to select the two edges of the driveway. And there we have a surface terrain that just matches the grading for the corridor. And you could add other features. You could add other break lines here if you needed to, and those kind of things. So that's just a simple demonstration. This feature definition doesn't have the same material assigned to it. I think that was something we had talked about maybe adding another feature definition so that we could have that match. So before we turn it over to Eric for the planned production part of this demo, I just wanted to show two other scenarios where you may have some drive modeling that you would want to take a look at, and maybe a civil cell isn't the best way, or maybe we could use it in combination with a little corridor for a drive. So I went ahead and created a couple of different alignments and have some profiles here. So first I'm just going to start off by placing a civil cell at this intersection or at this driveway. And I'll just use the same one that I used previously. And I need to modify the direction here. So there we go. Drive looks pretty good, and I'll place that there. And then what I'm going to do real quick is just go ahead and modify the width of this driveway, if it lets me. So that's all the modifications I'm going to make on the drive itself. Now, what I wanted to show earlier is if we wanted to modify the center line, if we needed to move our center line of our drive, we could do that and our civil cell would automatically update. But because we have it drawn in two different files, we have a little bit of a challenge here. So it's not anything that we can't overcome, but it would just require us either to change files, or we could use the activate command from our reference file. This has some limitations. For example, you know, undo doesn't necessarily work as well. A couple other things, but I've activated this file. Now that file is active here, and I can go ahead and modify this geometry. So if I wanted to move my center line and maybe just snap it to a little bit of a lower point here, my civil cell adjusts for me and my model is updated for me. So to then exit out of there, we go back to our reference files and we deactivate that file. If you're using ProjectWise, it will ask you to check that file out, and you have to make sure you deactivate it. And then I don't remember if it's going to prompt you to check it in. I think you have to close your session and then you have to manually check that file in. So now I have a drive here with my civil cell, but I wanted to extend back to this point. For maybe for our profile, we needed to tie in further back. So what I'm going to do here is just create a new corridor, just like we would for a roadway. And I'm going to use my active profile. And in my template library, I went ahead and created a template, just called it driveway, with some simple end conditions. And I'm going to lock it to the start, which is the back of the drive. And then for the end of it, I'm going to snap to the drive civil cell. And you can see I have a corridor then with some grading. For the grading where you have the where the civil cell was placed, we could follow the same sort of workflow that I just showed. For my last example, maybe you have some sort of irregular shaped driveway where you have a turnaround or something that we needed to reconstruct. So what I've done is gone ahead and created a center line and given it a profile, and I just used the horizontal geometry tools to create the edges of my driveway. And I've gone ahead and profiled those on the southern edge and on the eastern edge, or the back of the drive here. And for the back, I've just made it tie into existing or match existing, and then defined a profile for these three elements along the southern portion. So I'll show how I did that on these northern three pieces. So in my profile view, I have a profile view of this middle element, which is kind of parallel to the center line. So I want to use profile by slope from an element. And when I select that, I can use my center line as my reference element, and I have a slope of 1%. And my data point through all those, my profile is drawn here. And I don't have my feature definition set correctly, but we'll continue on. So then to get that to show up in our 3D view, we'll define that, or we'll set that profile to be active. Next, for the chamfered piece, I can open another profile view here. And since I had already done this previously, I had used the profile intersection points to define the edge of pavement if you can't see it, and the edge of shoulder, and then this magenta point is the other drive piece that we just profiled. So then I just created a complex profile by PI, and I snapped to those pieces, to those points, and again I went ahead and made that profile active. And then the last piece was this back chamfer piece, and select that, select my plan view. And again, I went ahead and used the profile intersection point, so it defines the point here. And then because the rest of it ties to existing, I can just create a line from that intersection point to the existing ground. And then I will also set that profile as active. So the next thing that I want to do is go ahead and create a terrain from these elements here. And I'm just going to set my feature definition to proposed pavement surface, and I can go ahead and locate the elements that I want to add. So all of these driveway pieces and my edge of shoulder. And I'll reset when I'm done. And that's going to be a boundary, and an edge method will be none. So now we have a surface through the pavement. Now what I want to do is go ahead and make sure I add in my center line as a break line. So we'll go to feature management and add features. And I'm going to select the terrain from the 3D view. And then I'm going to select the element I want to add from my 2D plan view here. And then I have my feature type set to break line, and then I'll reset and add my break line. You get something a little bit weird. Oh, it's triangulating the center line back through the pavement here. I guess we probably should end our profile at the edge of shoulder. Okay, so I just did a quick undo just so that the surface terrain looks like it should there, or as good as it should. And then we're going to go ahead and apply a surface template to add our pavement thickness here, our pavement buildup. So I'm going to go ahead and I'm going to select under drives, I'm going to select the residential buildup number 2. And then I'm going to locate my terrain model and accept through the prompts. And there we have our driveway with our pavement buildup applied in our 3D model. And then for the remainder, we could go ahead and do the modeling techniques that we just talked about.
Okay. That's all I have, Mark. Turn it over to Eric unless we want to pause for any questions.
Okay. Yeah, I don't see any in chat, so I'm going to go ahead and start up, Eric.
Okay. Let me get the thanks, Matt. As Matt mentioned, when he placed the civil cells, there were a couple of them that didn't quite come in right. So that's something that we need to review. So most of those civil cells were created probably 4 years ago and have not really been reviewed since then. So I know he pointed out a couple of things on the civil cells that we need to clean up. So we'll do that in the coming week or two. So I wanted to just jump off that and look at just plan and profile things for driveways. And I've got a couple of videos. So as Matt said, I kind of feel like I'm cheating when I play a video, but I debated whether to go live or play videos. And I do want to mention one thing. I didn't talk about the direction the driveway is defined, or didn't think about it until I talked to Matt earlier this morning. And I had set mine in my example starting from the center line and going out. And that when I talk about it in the video on the profile, it's not necessarily going to go left or right. So what Matt had suggested as a convention is that if it's on the left side, like this one is, upstation is going down on this, that we should start and work back towards the center line. So starting that from this side and defining it that way. If it's on the other side, then just starting from the center line and going out. So in my example, this drive started here and went out, so they're going in opposite directions, and it doesn't work out real well on the profile, and the video kind of talks about that. So I didn't think about starting it from this side and going that way, and the direction of it comes out better on our profile when you do that. Another thing I should mention too is I looked at this. I talked to a friend of mine that works for a consulting firm, and he said they more or less just go into showing plan and profile type sheets for their driveways, and they're not really showing a separate plan detail and separate profile detail. So I'm not going to clip a plan and profile sheet for a driveway, but that's an option on a more complex driveway with curve data and stuff. You'll probably want to just make plan and profile. So with that, I'm going to go ahead and jump in here and play a couple videos for you. If I get the right one, there we go. I have a few different driveways that I'm working on some modeling, and I do want to cut some sheets and just look at different options for sheets. So the first thing I'm going to do is take a look at ODOT sample plans. And in the sample plans, they do have an example of a drive detail sheet where they've got multiple drives on one sheet. So I'm going to start by making a plan sheet like this, and then we'll take a look at profiles in the next video. So to get started, I'm going to change to the Ohio DOT workflow, and in the apps tab, I'm going to create a new design file for my drive details. So I'll just expand the category just a bit. So in the drop down, I can see those and read those. And I'm going to pick the roadway category and then click off to apply that filter. And I'm also going to filter by sheets. So looking at my list of files, I can see that there's a drive detail file. So I'll check that on. And what I want to do is create a container file. So I'm going to use a file number of 000 for this. And you can see when I type that in, it changed to the design seed. So I'm going to go ahead and create this file. And then after the file is created, I'm going to attach the references for the things that I want to show on my drive detail sheets. And then I'll rejoin the video after I get that complete. Okay, so I have my references attached, and I'm ready to put a couple of these drive details on the sheet. So let's go to the Open Roads Modeling workflow. And from there, we'll go to the Drawing Production tab, and we'll use the Name Boundary tool. So I've got a couple different options for how I could do this. I could use the civil plan item, or I could just place a rectangle and do it that way. I'm going to go ahead and use the civil plan item because that gives me a couple of advantages. So I'm going to use the ODOT option for plan only and set my detail scale to 1 to 5. Turn off the start and stop location and just click in the start location and then pick my drive that I want to start with. So I'm going to start this at 5 feet before the drive. So I'll put a starting location of -5 here. And for the stop location, I'm going to tell it 0 plus 75. Now it's defaulting to a length of 125 based on my scale and my drawing seed. So I'm going to go ahead and change that to match the length I've got here. So I have 80 feet total. So I'll set the length to 80. And then I've got left and right offsets, again, defaulting to the values defined by the drawing seed and the scale. I'm going to go ahead and leave that at -50 and 50 for now, but I'll probably change that. So I'm going to click in my plan view, and I can see the limits of what it's going to place in my sheet. So it's pretty wide. I probably don't need it that wide. So I'm going to
make that a little narrower. So I'll say minus 30 and 30 for my offsets. And that probably is going to work a little better on my sheet. Lengthwise, I may be a little too long, but I'm going to go ahead and leave it at that. So I'm going to give another data point and a third data point to accept placement of the name boundaries. And it brings up the create drawing dialog. So I'm going to name this one Plan 1. And I have the option of one sheet per design file, and I can create a separate file. I'm just going to go ahead and create the drawing and sheet models in this file. So in my drawing model, I'm going to change to my 1 to 5 scale, and I want to do the same thing, make sure that's set in the sheet model for the detail scale. So I'll go ahead and hit OK, and it's going to create a drawing model and a sheet model, and then attach the drawing to the sheet. And it's just putting it in a default location. So we're going to come back and move this a little later. But the intended workflow, as far as what Bentley intends, is in the drawing model. This is where I would place any annotations, and then that would carry through to my sheet model. So let's go back to my design model. And I'm going to place another name boundary for this second driveway. So we use the name boundary tool again, using the same plan only drawing seed, 1 to 5. Turn off start and stop location, click in start location, pick the center line. So again, I'm going to start at 5 feet before, so I'll use the starting location of -5. And let's try it 75 feet on this one as well. So I'll give a data point, and it'll show me the name boundary. And this is something I see it occasionally do. It's showing me actually 2 name boundaries. And I have not talked to Bentley on this. I don't know if that's a bug or just a tolerance thing here. But I noticed that if I just change the length, just make it just a little longer than the total length here, that it'll only have 1 sheet. So I'll change that to 81 feet, and I can see I'm only going to get 1 name boundary. So I'll go ahead and accept that. And name this one Plan 2, or I can name it Drive 2 or Drive in the Station, or whatever I want to name that. It's the name it's going to use for the drawing model. I want to make sure I change the annotation to 1 to 5 in my drawing model. And in my sheet model, I'm not creating a new sheet. I'm going to add this to the previously generated sheet. So if I pick on the list, I can see that sheet that's already been created. So we're going to add it to that, and I'll change my detail scale here to 1 to 5. Go ahead and hit OK. Okay, when the process is done, it opens the sheet model, and here we're seeing a bit of a problem. My second driveway is out of scale for my sheet. So this is something that I have reported to Bentley, and they have logged a problem for this. So it should be fixed in a future release. But it's an easy fix. So what I need to do is just go to my attach tools, and if I see my first reference, I can see it's at a 1 to 5 attachment. The second one brought it in at 1 to 1. So I just need to change this to 1 to 5, and that'll put it back into scale. So now on my sheet, I can move these details wherever I want. So in the sheet model, these are just references to the drawing model. And I can go ahead and pick the first one and just rotate that. And rotate this 90 degrees about the Z, and just put it over here somewhere. I can refine that, move it a little later. The second one, I'll rotate that as well. Again, 90 degrees, and we'll just kind of put that somewhere in here. And I can just use the move function for my references to move those where I want. So that's the general workflow to add multiple details to one sheet. As I mentioned, you could have done that with just using the rectangle option, but that doesn't give you the annotation, which is going to give you your north arrow.
So that's all for that video. I used a 5 scale, and I think the sample plan is a 10 scale, so that's why mine are a little bigger on the sheet. And then from here, I can just go do any annotation I need for that. So I think the key step there that most people aren't aware of is I can add details to a previously defined sheet. So I can have as many of these as I want, depending on the scale, move them around where I want on the sheet. So next example is a profile.
I have a few different driveways that I'm working on some modeling, and I do want to cut some sheets and just look at a different.
Okay, so let's go to.
I have a few different.
Here we go. go ahead and play this one.
So what I have open here is the example and ODOT sample plans for drive profiles. And really, as I look at this really kind of looks more like cross sections than it does profiles, and they're all kind of jumbled up on top of each other with no real spacing. So if there were any underground utilities, drive pipes, things like that, there's no room for that on this sheet. If you had things like maybe labeling your right-of-way locations, that's going to be pretty tight to fit those in there as well, wherever the right-of-way might be coming in, existing right-of-way. So I'm not real fond of this sheet, and honestly, we're not going to be able to generate a sheet that looks just like this with Open Roads. It's going to look quite a bit different. So let's take a look at the options that we have with Open Roads to generate a profile sheet. So I'll jump over to Open Roads itself, and I've already created a design file. So I have a GF000. So GF is a sheet file. I'm under Roadway Sheets folder. I use the 000 for my file number, which is going to be a container file, and that uses my design seed. So I'm in a design model and have my references attached. Let's go ahead and open a profile window. So I use element selection. Let's select this driveway, and from the pop-up menu, we'll open a profile model, and I'll open up View 2 and just click in View 2. So it does orient this for profile, but I'm not seeing my graphics. So this is a known problem, and all we need to do is open our level display dialog. And with that window selected, click on the profile attachment and turn on the levels that we want to see. And I'll just go ahead and fit that in. Okay, so the first one that I'm going to place actually is a driveway up station on my center line is going down. So this is actually to the left. So you can see my drive center line was defined from the center line itself and going out. So up station along the drive is going to be shown to the right. So right off the bat, all those drive profiles that were shown in our sample plan are going to the left, and they're shown to the left. Well, when I'm doing this in a profile mode, it's going to go to the right. Up station's always to the right. So that's something to keep in mind if you want to do this. And from a profile mode, it's the left ones aren't going to be on the left. They're going to appear that they're on the right. So that's something that you're going to pay attention to.
So I'm going to pause that video right there. And as I said in my introduction, had I started this from this end and defined it going the opposite direction, I wouldn't have that problem with the drive on the left going up station to the right. So after I get through both videos, I'll just open a design file where I define it the other way and just show you that I'll add it to the same sheet and show you that
on the plan. And you may or may not find that acceptable, and we'll show you the option to cut these as cross sections, which will take care of that problem at least, but introduces some other interesting things. Okay, so what I'm going to do is go to the drawing production tool. So I'm in the Open Roads modeling workflow, and they're drawing production, and we're going to pick the name boundary tool. And I'm going to place a profile name boundary using the profile only option, and we'll set our detail scale to 1 to 5. So for my start location, what I can do is click in the profile window, so that's active, and I'm going to start somewhere before the drive profile itself. So I'll say maybe -10 is a starting point. For stop location, I'm going to go maybe to 1 + 15 or 115 feet. I can see that at the 5 scale, I have 125 feet available. So those two, 10 feet and 115 is 125. So I can click in my view, and that'll show me my name boundary limits. And now I want to change my vertical exaggeration, which is going to change my available profile height. So this particular drawing seed was defined, assuming I'm doing a profile only that's going to occupy the full sheet. Well, we're going to occupy only a portion of the sheet and add a couple of drive profiles to it. So I'm going to change this to a 1-to-1 exaggeration for a drive profile. Typically don't show those exaggerated. You may or may not want to. And that changes my available profile height quite a bit to 90. Well, let's change that to maybe 20 feet or so. That's going to pull that down quite a bit. Let me make that just a little bigger. 25 might work well. Okay, so one thing I want to keep in mind, this is not a 1-to-1 view. So what I'm seeing as far as my horizontal and vertical is exaggerated a bit. So in my exaggeration here. If I go to my attributes for my view, I can change this to 1 to 1. And that gives me a better indication of what's going on with this and how that might appear on a sheet. So I can tell that I may want to give a little more room at the top. And so I'm not going to place this yet. So I don't want to do the create drawing yet. I'm sorry, I'm going to place it. I'm not going to do create drawing yet because I'm going to shift that a little bit and move that up a little bit before I actually create the drawing. So I'll go ahead and data point to accept that. And what I want to use under the tools is adjust this profile name boundary. So I'll pick that profile, and then it's going to adjust based on my elevation data spacing. So just having run this and getting ready for our presentation, I know if I just move that up one unit of 5 feet, that it's going to work out better for my annotation. Okay, so I have that defined. I'm going to go ahead now and clip a sheet from that. So in my name boundary option here, I'll pick the little icon there that brings up the name boundary manager. Looking at my profile group, there's my profile boundary that I created. So with that selected, I'm going to turn on the show the create drawing dialog, and I'll pick this icon to initiate the creation process. So I've got the option to send this to a separate design file, 1 sheet per design if I want to do that. I'm just going to keep it in the name. I'm going to keep it in the file that I'm in, and it will make a drawing model using the name. I'm going to change my drawing model scale to 1 to 5, and I do want to change the annotation group to use one that we've set up for a drive profile. I want to make sure I have a detail scale 1 to 5, and I'll go ahead and hit OK to create my drawing model and my sheet model. So there you can see how this is coming across on the sheet, and this is what I was saying, that even though this driveway goes to the left, it's always going to show up station to the right. So that's something that when I annotate this and put a station on here for my drive, I might want to make a note here that it's a drive to the left, even though that stationing is shown across to the right. Now, there's some other things I could have displayed, and I forgot. I meant to do this before I clipped my sheet. So I'm going to go back to my multi-model view, and in my profile window, I'm going to add a 3D cut. So I have my 3D model attached, and what this is going to do is allow me to show anything that's in the 3D model on my profile. So it's going to read that 3D model and show those 3D elements. So I've got an option here, placement method by corners or full profile. I'm going to do by corners, so I'll accept that. And it's asking for a start point and a stop point. I'm going to start just right in here somewhere. I'm going to stop right in here somewhere. And what it's done is it's going out and read the 3D elements that are in the 3D model, and it's showing those. So I can see my pavement layer, my shoulder layer, and then my drive buildup. So if there were any underground utilities, I would see those show up here as well. So it's just whatever's in the 3D model. If I don't want those pavement layers, I need to go to the 3D model and turn those off in this particular design file itself. Go to the 3D model here and turn those layers off. Okay, so that should carry through to my drawing model, and I can see those are shown there in my drawing model and as well on the sheet model. Okay, let's go ahead and add a second drive profile to this. So I'll go back to my multi-model view, and I'm going to select another driveway and open a profile view for that. I'll use view 2 and just click in there. And again, Control E brings up level display, and I can turn on my existing and proposed ground lines and do a fit. So let's add a name boundary for this. So we'll place name boundary, profile only 1 to 5. And I'll make sure I click in my profile view, and I'm going to start the same thing, 10 feet before, and I'll go, I go 115, yeah. And I'll use the same values there. Again, I'm not going to create the drawing. I'm probably going to shift that up a little bit. So I'll just place the boundary, and I'll use that tool to adjust that. I pick the boundary and just move it up one of my grid units. So let's go ahead and open the name boundary manager, and I'll pick the second drive here and do the same thing. Now I do want to make a change here on this one. I am going 1 to 5. I do want to make sure I use my profile annotation. for a drive profile. But under my sheet model, I'm not creating a new sheet. I'm going to add this to the sheet that was previously created. Make sure I pick a detail scale 1 to 5 here as well. And I'll go ahead and OK that. So it creates the drawing model and attaches the profile. And I can see I've got the same problem here that I had in the plan. This attachment's out of scale. So again, we have reported this to Bentley. Hopefully this will get fixed in next release maybe. And to fix this, it's the same thing I did in the plan view. I just need to open the reference dialog, change the attachment scale here. And now I can move this second profile wherever I want on my sheet. So that one looks pretty good. I need to line these up a bit, can shift those around and do whatever I need to do there. So like I said at the top, we're not going to be able to duplicate that exact type of sheet that was shown in the sample plans. But the idea here is just showing the information and getting that information out to construction. So that's the process using a profile mode. Now let's take a look at this using a cross-section mode. So what I have open.
Okay, one more canned video for you here using a cross-section.
Let's take a look at using a cross-section approach to generate some drive profiles. So what I have is a design file I've already created, my XS000 file. So that's in my 400 engineering roadway sheets folder, and as a 000 file, it's a container file. And in that file, I have just one model, the design model. So I've already attached my plan view information and the information I need to generate my profiles. So to do the cross-section mode, I need to display the 3D model. So I'll just hold down the right mouse button and under View Control, pick two views, Plan and 3D. So I can see the 3D model. So let's go ahead and put in our name boundaries for this. So under Drawing Production tab, I'll use the Name Boundaries tool. And we're going to use the Civil Cross-Section mode. So for my drawing seeds, I'll use the 5-scale drawing seed. And for the start location, I'll just click in that field, pick my center line, and now it's dragging along, and I can go ahead and pick my start. So I'm going to use the driveway here and just snap to that intersection location. And I'm also going to use that same location as my ending station. So that interval doesn't matter in this case. So my offsets, I'm going to the left and the right. I'm going to tell it to the left go 0 and, oops, let's change that to the left. Let's go minus 70 and to the right go 0. So my left is this side. So I'll go ahead and put that boundary in the file. I'm not going to create the drawing at this point. So I can see in my 3D view the name boundary that was placed for that. Let's go ahead and add another name boundary for my next driveway. So it's the same thing. I'll select start location, pick my center line. We'll let it snap to my drive element. I'll use the same station as my ending location. And this time my left offset is going to be 0 and my right offset is 75. So I'll place that one in the file. And there's my second name boundary. Let's place one more. Now this one is at a slight skew angle. So instead of using the civil cross section, I'm going to use the cross section by 2 points option. Now I want to make sure I'm adding it to the same group. I don't want to add it to a new group. I think it defaults to new when you open the dialog. So I'm going to pick the Centerline State Route 185 group, and I'll pick the Centerline itself and give the starting and ending location and accept that. And I see my third name boundary comes in. So let's go ahead and create a sheet from these 3 name boundaries. So I'll pick the Name Boundary Manager dialog, and in the cross-section group, I can see my group and see the boundaries that were created. So I have Show Details toggled on. So I'll pick the Create Cross Sections dialog icon. So again, I have the option to send this to separate file, 1 sheet per file. I'm going to keep it in my active file. I have 1 to 5 for my drawing model annotation and 1 to 5 for my detail scale on my sheet model. So I'll just go ahead and OK that. So all 3 of these are going to fit on 1 sheet. It's going to make a name or it's going to make a drawing model for each of those. And I can see that this isn't the prettiest thing in the world, the way this comes out. But if you think about it, cross sections are placed on the sheet, starting from the left side of the sheet to fit them on. And this one's only showing a portion to the left. This one's only showing a portion to the right, and this one to the left. So I could move those if I wanted to line the centers up on the sheet. I don't know if that's necessary or not. Of course, when I cut that name boundary, I could have set a wider area for that. The other thing you'll notice is we have the cross-section table here, which you may or may not want. So if you don't want the cross-section table, if I go back to that individual drawing model, I can just delete that table. So again, this is cutting through the model. It's going to show me the pavement layers that are shown in the model. So obviously this method isn't perfect either, but it does have advantages that if it's to the left, it's shown to the left of the center line. If it's to the right, it's shown to the right of the center line. So that's just a quick example of cutting some drive profiles in a cross-section mode.
Okay, so I do just want to revisit that one more time on the direction that I was creating my center lines. And what I did was added another one here. I just added this one in this morning and defined it starting from this side and going towards the center line. And I added that to my profile sheet. So here's my profile sheet where I added that one in. So since it starts 0 out on the left, goes to the center, it's going in the direction we would expect. So that's a better workflow than what I had in the videos. So that's all I've got. Let me jump back over here and I'll stop sharing my screen. And unless there's any questions, I'll just turn it back over to Mark.
Okay. Yeah. I didn't see any questions popping up in the chat. If you would like to ask a question now, you can unmute yourself and then ask your question. Okay. Well, if we don't have any questions, thank you for attending today, and look forward to seeing you again in a future CAD webinar. Thank you for attending.